Let's do a few example problems of calculations with the binomial model. So this is just the WeBWorK set binomial distribution. I just took some screenshots of the different problems. So number one says if x is a binomial random variable, which is nice. It tells you that. You don't actually have to figure it out yourself. The notation here, probability of x equals k, just means the probability that the binomial equals a certain number. You get a certain number of successes is k. So it tells you n equals 5, k equals 2, p is 0.2. So enter n and p into this. N is 5, p is 0.2. And then it wants the probability that x equals k, where k is 2. So you want the probability of 2 successes. So the easiest way to get that is just to look up in the table here. It says it's 0.2048. So that's what you'd enter into WeBWorK. I can't enter it here because that's a screenshot, but that is the number I would enter. Problem 2 is similar. You just have to watch what they're asking for. The first one says n equals 8, p equals 0.7. So you enter those. And then it wants the probability that x is less than or equal to 5. So you can go to the lower tail, enter 5 here, and it'll automatically tell you that's 0.4482. So A is 0.4482. The next one is similar. N is still 8, but now P is 0.1. 0.1, come on. And you want the probability that x is greater than 5. So now you're not actually including 5 itself. You want bigger than 5. So you need to start at 6. And GeoGebra is going to tell you this is 0. It's not exactly 0. It's just rounding to 0. So you can go up here to the settings. I clicked the 3 horizontal bars, which somehow these days means menu or settings. But when I click that, and then I go into the settings here, I can change my rounding. Let's go all the way up to 10 decimal places. That's probably overkill. But if we wanted the exact value, it'd be 0.00002341, which makes sense. If the probability of success is only 0.1, it's very unlikely to get more than 5 successes. This is one where you could probably enter 0 into WeBWorK and it wouldn't give you any hassle, but when in doubt, more decimal places as usual. For letter C, n equals 7, p equals 0.8. So n equals 7, p equals 0.8. And then x is less than 6. So less than means lower tail. Less than 6, not less than or equal to, means you have to start at 5. So 0.4233 will probably be fine here for that one. This one is a little different. A quiz consists of 10 multiple choice questions, each with 4 possible answers. For someone who makes random guesses for all the answers, find the probability of passing if the minimum passing grade is 45%. That's a very generous passing grade. Okay, so minimum passing grade of 45% out of 10 questions means you need at least, well, it's not super hard, but you multiply that, 4.5 correct. So really, let's format this so we can get it all on one page better. So 10 questions, 45% right means you need to get 4.5 correct. So really you need to get 5 or more correct. So that's what you're going to do in GeoGebra is 5 or more correct. There are 4 possible answers, and if you're randomly guessing, you have n equals 10 and p equals 1 over 4, or as a decimal, 0.25. And GeoGebra is fine if you enter 1 over 4. It'll go ahead and auto-complete that to the decimal of 0.25 here. So you need to get more than 5 correct. No, 5 or more, because that's, 5 would be passing, so 5 or more correct would be, you go in here, upper tail starting at 5 would be 0.0781 is probably your answer. That's the number you'd enter in this box. Number 9, similar, but sounds more complicated. A psychologist believes that 80% of male drivers will, when lost, continue to drive. Weird wording, but okay. So that's our p equals 0.8. Find the location rather than ask directions. So the psychologist took a random sample of 36 male drivers, so n equals 36. And if the belief is true, so using these numbers, determine the probability that less than 73% say they continue driving. Less than 73% of 36 people is less than, just multiply these two, and I have a calculator handy here, which you can't see, but I'm typing in 0.73 times 36. 26 is 26.28, say that. So really, it's 26 or fewer. So you go into GeoGebra, do p equals 0.8, n equals 36, and do lower tail starting at 26 would give you 0.1676 if I round this. So 0.1676 is the number you would enter in this box. You'll get different numbers, but it's the same idea. Some of the other problems in this set aren't just type in the numbers, you need some other stuff. So we'll talk about the other stuff you need to do the rest of these problems in future videos.